Good morning or afternoon or evening, depending on where you all are. This is the latest of the Show and Tell Google Hangouts on air sessions, managed by and offered to you by the three special interest working groups that work together within Igloo and Illuna. That's the interoperability group, the linked open data group, and the analytics group. In a moment, we're going to be sharing some links through this showcase application that is built into Google Hangouts. That includes links to the Q&A for this session, slides and information about this session, and a variety of other things. So I'm going to keep this intro really, really brief. I want to make a couple of announcements. One is that Igloo and Developers Day are coming down the pike really quickly, and so if you haven't already registered and you're in the vicinity of Trondheim and interested in going, it's looking like we have really, really great schedules shaping up for those events, and I encourage you to register and attend. And then also, the Q&A form for submitting questions for the Q&A sessions at Igloo are online. I just sent that to all three of the special interest working group lists in the last week or so, but if you don't have that link, contact me and I'll provide it to you if you have something you want to ask of Ex Libris. The only other thing is that we look to you, the community, the user community, for ideas for these show and tell sessions. So if you have anything related to linked open data or interoperability or analytics or any other topic, please do get in touch with any of the coordinators of the three groups. That's myself for linked open data, John Krug for analytics, and Mehmet Chelik for interoperability. So with that, I'd like to introduce our speaker for today, who is Steve Meyer, who's the data strategist at the University of Wisconsin-Madison. And he's going to be presenting on sort of incorporating external linked data into their discovery interface. And at the end, we'll do the standard sort of Q&A moderated by Mehmet and I. But submit your questions through the Q&A interface as we go, and then they'll be in the queue and ready to be answered when Steve's done with his presentation. So with that, I'm going to hand it off to Steve and have him
okay.
I guess.
So just a moment. I'm going to try and share my my screen, so I can show my slides. So can everybody see the opening slide here?
I've got it.
You got it? Okay. Sounds good. So thank you for inviting me to talk about the work that we've done at the UW-Madison libraries, and thank you to Mehmet and Laura and Corey and John for organizing these sessions. So as the abstract mentioned, this talk will be pretty technical in nature, and my goal is to share the work and even the code we are using to experiment with linked data in our Discovery UI. The code examples you will see in this talk are written in the Ruby programming language and should be simple enough to convey my points about working with linked data. And then also I just want to mention that a lot of the work here is really sort of the culmination of working with linked data and a former colleague at OCLC, Karen Coombs, and just sort of a plug, they've got their developer network has a great series of linked data posts for anybody who's more interested about this. So first of all, we've posted sort of a position paper outlining the philosophy that underpins the experiment that I will be describing today. Today there are many large-scale linked data initiatives underway that focus on redesigning cataloging by reorienting it towards linked data. And we think that in addition to these major projects like BibFrame and WorldCat linked data or the RDA registry, libraries like ours should begin parallel efforts to experiment with linked data in the library discovery systems. And specifically, we should focus those efforts on connecting external data sets not traditionally curated by libraries. And we sort of go into that at that link right there. So what exactly have our experiments produced? We have an alternate version of our production catalog that uses linked data to display info cards or knowledge cards about the identities found in MARC records. And so this URL is the URL to that version of the catalog. It contains -LD for linked data in the domain, and that really triggers the linked data functionality. I've also included a few sample records where you can sort of see some of the examples. I've got some of those up So you can sort of see, we have our general catalog display, normal bibliographic description, and then we've been able to pull in some information from a couple of remote sources to display biographical information, to get, say, the alma mater's notable works, and a couple of other data points. So, this is basically what we're going to be talking about today, the info card. It's really pretty simple, and we want to add this knowledge card or info card about an author or other identity found in a bibliographic record. Basically, brief biographical information. So what does it look like in context? So this is, right here, is one of the examples that I really like. It's a screenshot, or this is really the one of our records. And if you click on that link in the presentation in the slide deck, it'll just go to a screenshot. I have it also captured here in my browser. If you scroll past the display of the marked bibliographic data, next it's going to display, similarly to the previous ones I showed you, that information about, in this case, Linus Torvalds. We've got the bio, we've got the birth date, the university he attended here, and some notable works and some film appearances. And what I love about this record is the way that it provides highly relevant information the bibliographic description does not, but which is closely related. So while the subject headings for this book, if we were to sort of go back to the normal bibliographic description, indicate that this book is about Linux, in this info card we get some information. It really asserts that this is considered the creator of Linux. And that's really relevant to evaluating the value of this title. And in this case, the notable works include software, a category of sort of intellectual work that's not collected and therefore not described by libraries. So what this talk will be about is how we retrieve and display this data in our catalog. So to understand the data integration, we should share some info about the systems involved. It starts with our local catalog. At the UW-Madison libraries, we have a really talented group of developers that have built an extensible user interface capable of these kinds of experimental enhancements. Our backend system is Ex Libris's Alma library services platform, and we are able to do this work because it has a comprehensive set of APIs. Their list of APIs are growing. And just this spring, we learned about the new JSON LD integration API from Josh Weissman at Illuna. And once we learned about the existence of this API, we jumped at the opportunity to fully integrate these linked data experiments into our local catalog. So a crucial system also at the heart of this work is OCLC's Virtual International Authority File, or VIAF. VIAF combines multiple name authority files into a single source, and very importantly has links to linked data representations of the entities described in those authority files. And finally, there are 3 data sets that we are targeting to get data for display in our knowledge cards at Getty, DBpedia, and Wikidata. So at a high level, this is an abstraction for how our library catalog sits at the center of all these systems to crawl the web for knowledge card data. After we load the standard information for a catalog record, the Discover UI makes a subsequent AJAX requests back to the library catalog server to kick off the data crawl. It starts by asking the Alma JSON LD API if it has any URIs for the creators identified in the MARC record. When those are found, the system goes to VIAF to resolve related URIs for Getty, DBpedia, and Wikidata. And with those URIs in hand, we can then query those systems for the info card data. So taking a closer look at the details, here's a portion of the response that comes back from the JSON LD API. Our software retrieves creator data that includes URIs based on Library of Congress name authority file authority control done by our catalogers in Alma. And so the first step determines whether we can continue looking for more data. If we find data like this, we're off. So now I'm holding on to the URI for an LCNAF name, but as I mentioned above, VIAF is the identity hub, and we need to figure out what the actual VIAF URI will be. And this is a slightly trickier thing to do than it may seem at first glance. This was a surprisingly involved bit of work, a bit of the work required to make this happen. So you probably noticed that the JSON LD response included a URL for VIAF as well. However, this is a lookup URL only. That VIAF URL contains the LC name authority file ID, and making an HTTP request to it will return an HTTP redirect response, an HTTP 303 see other response specifically. That URI is only used to resolve the real URI for the entity in VIAF. But how do I find that real URI? So I cannot emphasize enough that if you're going to work with VIAF, you should take a close, you should look closely at OCLC's documentation to understand exactly what the various versions of their URIs and URL patterns mean. They have a very good design according to linked data principles, but it is not entirely obvious necessarily at first, especially if you're sort of new to this space. For example, notice that the difference between the second and third URIs on the screen, the second is the identifier for the real-world object, and the third is the identifier for the document or data about that real-world object. The difference between those URIs is just the trailing slash. So fortunately, I can use the data I already know to ask the graph, the graph that is returned from a VIAF response. So this is really a very simple process. Assuming that I have a variable that points to the entire VIAF graph loaded in memory, I can do a simple graph query to find the VIAF URI I want. I simply have to query the graph specifying that I want the triple, where the predicate is schema same as, and the object is my LCNAF URI. So this produces the following triple, and I can pull the VIAF URI off the subject of that triple. It's this one right here. So next up, I want to use a similar process to find all the URIs of the linked open data entities that I'm interested in. This time I'll be constructing a query based on the subject and the predicate. Now, because VIAF acts like a great hub to a huge number of other data sets on the web, I'm going to have to inspect the set of schema same as results. Presently, I'm picking the relevant URIs out by defining a URL pattern. And this is not great, but I'll come back to this a little bit later. So as I mentioned, that previous step is repeated 2 more times because I happen to be looking for 3 URIs. So at this point, assuming the best case, I am really running at full speed, and it's time to start fetching the last pieces of data. One of the big considerations is whether to crawl or query for the data. Crawling would be a process of making simple HTTP requests to find data about the entities. However, if I were to crawl the data for Linus Torvalds, for example, the data at DBpedia would assert that he has 3 notable works. But as we saw, those works, such as the Linux kernel and Git, would be referenced by URIs in the data for Torvalds. To get a display name or label for each of them requires subsequent HTTP calls to those URIs. As you can imagine, these HTTP requests will begin to add up very fast. The alternative query method is to utilize the SPARQL endpoints for each data set and define a SQL-like query so that a single HTTP request gathers more data. Ultimately, in weighing the consequences of each approach, because we are working in a web application context, making fewer HTTP requests using the SPARQL approach wins out. So here is an example query. And I'm going to sort of try and see if I can load that in a separate window. It retrieves all of the people that the artist Pablo Picasso was an influence upon. If you look at this sort of web browse view, you can see there are 53 assertions in DBpedia. And so Picasso was prolific and influential. So for just this one data point, we would need to consider the impact of 1 versus 54 HTTP requests. All in all, we're making up to 8 SPARQL queries per identity when building our knowledge card. And so that really sort of greatly reduces it. So now that you understand the basic data flow, let's consider the code. This software, its warts and all, is available for you to try out and poke around with at github.com. It's a Ruby gem called bibcard. A gem is a packaged library written in the Ruby language. At this point, we have not pushed it to the public Ruby gems repositories, but there are manual instructions for installing it in the README file. Just to get a few things out of the way, this is still an experimental reference implementation, so buyer beware, caveat emptor, etc. But let's dive into this. So I cannot stress enough that the context for this work impacts the design, and we are explicitly attempting to enhance library discovery, and therefore we're working in a web application development context. So there are a few constraints imposed in web application development that guide and shape the design decisions. First, we believe that our users expect our systems to be fast and to respond quickly. However, what I laid out for a data flow previously is an inherently slow process. It relies upon multiple remote data sources that are not under our control. To that end, we're taking advantage of web app development techniques to deliver some information quickly. First, we want to be able to utilize caching. We do not expect the data to change frequently, so we should not request it frequently. Additionally, this is extra information, so we add it to the page asynchronously after the primary page content loads. So, and the second consideration is based on thinking about the developer here. The predominant paradigm for web applications is object-oriented programming, at least in our environment. And so as much as possible, we want to make working with this data similar to working with other data in the application. So bibcard, therefore, has 2 primary responsibilities: retrieving data in a way that can be cached and which can be used to instantiate a person object. So at its core, bibcard works by fetching linked data in the form of RDF triples when given either an LCNAF URI or a VF URI. In the code displayed here, the entire process described in the data flow section of this presentation is encapsulated in this call to get person data for a particular URI. The data variable is then a string of 0 or more RDF triples that I'm going to call a micrograph. So using this concept of a small graph from diverse data sources has been useful when trying to build out info cards in our library catalog. So the 24 N triples that are displayed on the screen comprise all of the information that would be needed to display to display this info card about Sir Tim Berners-Lee. So the screenshot is from an earlier iteration of our URI. What this means in practice is that the bibcard code is making those SPARQL requests, retrieving the JSON data response, and translating them back into N triples. I chose N triples just because it's the simplest plain text form of RDF and therefore lends itself to caching. So this is a little bit of an awkward way to shepherd data around like this, but it has been proving useful. So now to the second responsibility, which is facilitating the instantiation of code objects that can be worked with easily. I don't want to dwell too long on this slide because you can stare at it later because we are sharing the slides. But at a high level, these are the major steps that the code in the previous slide do. First, retrieve the micrograph from cache or in real time, then load it into an in-memory RDF repository. Using that repository graph, again, do the URI resolution dance to find the VOF URI. And once you have that, instantiate a bibcard person object. So one new piece that's slipped in here is this Spira thing. Spira is a linked data ORM, or object RDF mapper, for the Ruby programming language. So given that you have RDF data in a graph, you can define model objects that will map certain triples to properties of those objects. This is the piece of the glue that helps bibcard cross the bridge from RDF data based in a graph to simple person objects that are easy to work with in the web application. The value of Spira in my use case is that I can keep my view code, as in my model view controller MVC application, clean. In this example, even though I have a heterogeneous data graph made up of triples, I can tie it all together with a person model object. And that way, I'm not writing queries directly against the graph in memory. And this means that my view code for working with linked data is very similar to the view code from the rest of my application. I have essentially sort of preserved the original triples from the linked data sources and that structure in the micrograph that I've created. I've chosen to let the model objects in bibcard mimic this structure very closely. So there's a person object that represents the VOF entity. The excerpts of code here illustrate how the VOF person entity relates to the Wikidata entity. You can also see that the way Spira maps core properties is similar to the design pattern established by the very popular Ruby on Rails web application framework. It's based on the active record associations. In this case, the property method finds a single field by its predicate and type. The hasMany method is a multi-valued field in a similar way. And this code then defines the attribute accessors or getters that you saw in the view code on one of the previous slides. So now that I've sort of gone over this basic overview of the code base, we are using to generate these knowledge cards in our catalog. I'm hoping that's been sort of enough of an overview that you can poke around the code yourself, maybe fork a better version of it. But let's talk about some of the less than stellar parts. There are a couple of bad parts in this code, and some of them may be my fault due to a lack of imagination for how to overcome a particular issue here or there. Others are based on some of the awkwardness that I find a little bit too common working with RDF data. First up, I do something really absolutely horrifying. I have to say it's downright terrifying from a linked data sense. And so I'm ashamed to say that this code modifies an identifier. But here's the issue. The VOF entity with a link to Getty data is a schema person. That's its RDF type. The VOF entity, therefore, kind of sensibly links to Getty's corresponding entity of RDF type, which is also schema person. This makes sense. However, the useful Getty data that I want for my knowledge card is attached to an entity of RDF type, which is the Getty vocabulary property person concept. And so finally, the Getty data set does not appear, at least as far as I've found, to link its own person concept to its own data for the schema person. So the end result here is that when I'm trying to get from what VOF knows about a person to data about the same real-world person in Getty, it runs into a dead end. So technically, I don't know of a way to follow the links that get me to my desired destination. So this would be one thing. If anybody knows how to solve that, please chime in. There's also code throughout that does stuff like this. It feels a little bit wrong. It sort of smells bad, but it is a surefire way to find exactly the URI that you're looking for, matching by strings. I'll admit that this may be just sort of due to my novice status working with RDF graphs. And finally, this is not so much a failing of the code, but does call into question the reliability of the entire project. we have to. There's a few places where you have to handle gracefully what could happen when an HTTP request might time out. These are remote data sources on the web. They go down. They're unavailable. And it's unclear whether some other client is hammering on the site or there's some other reason why it's down. But this does have consequences for this functionality that we're trying to add to our catalog. Namely, we can only treat this as a progressive enhancement if we are not completely caching the data in a local triple store. The general web caching then also needs to strike a balance. On the one hand, I want to cache for a decent amount of time so I can reduce my overall dependence on the remote systems. On the other hand, we don't want to cache data for too long when one of the remote sources was down and my cached copy does not contain all potential data. Alternatively, I thought that we could design the caching so it caches longer if all of the expected data was available and shorter if not. But finally, this is additive functionality, and we really only want to add it to the page via asynchronous JavaScript requests back to the server. We really cannot hold up the primary page load waiting on this data when it may not even fully show up. So that's another one of those pieces that, at least when we're running this off of live remote data sources, is a very strong design consideration. So having spent the amount of time it takes to get this experiment or prototype up and running means that I've been sort of reflecting on the nature of linked data and libraries quite a bit. Sometimes it feels like a miracle that this works at all. Really, this slide is a series of implicit thank yous and requests for various members of the library community to take a bow. I mean, first of all, thank you, catalogers. Your work on authority control has really positioned the 21st century library technology well. Thank you, vendors and national libraries and maintainers of union catalogs. All of the cooperation preceding linked data meant that you were easily able to slip APIs and data integrations into place to facilitate more sharing. Thank you to Ex Libris and OCLC et al. Thank you, library technologists and web developers. All of the people out there hacking and sharing in groups like Code for Lib or these Illuna Igloo interest groups have set a precedent for patterns for how to run with an idea. And in particular, thank you to VIAF and the folks at OCLC for that. The existence of a remarkable data hub that takes us outside of ourselves is really quite amazing. So without a door to the outside world, you can't get out of the house. And it's a good house, but it's also a pretty big, exciting world. So with that's the end of my presentation here. And I'll open it up for questions or comments.
Thanks, Steve. That's really great and interesting stuff. I am looking at the Q&A, and it looks to me like you might want to unshare your screen because we're getting that wacky tunnel. There we go. That's better.
Okay.
Mehmet, it looks to me like the showcase block on the live version of the broadcast overwrites the Q&A block, which keeps us from letting people submit questions. Can you deactivate Showcase and turn Q&A on so that maybe people who are watching live can watch, can ask questions? And I apologize to the audience that we did not enable a collecting of your questions beforehand.
Let me try.
I do actually have a couple of questions, so maybe I'll kick this off since I'm here. You early on talked about the crawl versus query question and some of the challenges around that and the pros and cons. And I'm wondering if you have any concerns with downtime of SPARQL endpoints or sort of unavailability of various different target systems as a problem for the query approach that you're using.
Yeah, definitely. However, one of the things that I found is that DBpedia, for example, unfortunately, it's such a great data set that I think a number of people have been very excited about accessing it, and some people really kind of hammer on it, or at least that appears to be somewhat documented on the web. One of the things that I've found, though, is at least the SPARQL endpoint for DBpedia in particular, when it is down, so is the rest of the DBpedia site. And so even if I were going to just try to make HTTP requests to an individual URI, I'd run into the same problem. But it is a definite concern. I mean, it's caught me up in days when I want to be sort of working on some piece of development, and it's down, and I can't make a request. So it's definitely one of the things that's there. I haven't seen that the SPARQL endpoints have been down more than the sites itself. We are sort of logging in our application some of the cases. We're just using sort of our normal web frameworks logging capabilities to note, oh, I hit something and it didn't respond.
Cool, thank you. That definitely covers my question, and I know that some of the biggest concerns I've heard about uptime and reliability are related to id.loc.gov, which doesn't really apply to you anyway because the Library of Congress vocabularies don't have a SPARQL endpoint at this time.
Yeah.
I guess the other one I had is I'm really impressed by the work that Wisconsin has done on that discovery layer, and I'm curious what that's built out in. Is that all homegrown or?
Yep, it is it's a pretty standard Ruby on Rails application on top of a Solr index. So we are consuming this. We are consuming the same data feed that we understand Primo to be consuming, and then so we get the sort of the multiple times a day updates that we know that records in our catalog have changed. We consume that and we just sort of index it appropriately.
So I think our audience still can't ask questions, unfortunately. So Mehmet, to show you what I see when I go, let's see here. I'm very quickly going to say I'm going to screen share.
I'm unable to enable Q&A during a broadcast.
Oh, okay. Yeah. Well, that's really too bad because I'm guessing, and I'm checking Twitter, it doesn't seem like anybody is reverted to asking questions there. Is it worth temporarily disabling the broadcast and then, oh, hey, somebody is testing the asking and a question came through. So how did they do that? I don't see the ability to do that on my own system. Well, in that case, maybe questions are coming through and we're just not getting any, in which case it could just mean that your presentation was comprehensive and covered what people are, what questions people might have about this, or that they need some time to process it.
Or hopefully they're actually going and looking at that GitHub repo and
yes, they're engrossed in
making forks and improving everything.
Oh, that's where it is. So the Q&A bar wasn't there by default because the showcase bar shows up over it. So to people who are watching on the Google Hangout directly, thank you, Tamsin. This is really helpful. If you go to the square grid at the top of your screen, you know what? I'll go to my screen and screen share and demo this so that you can see exactly what I'm seeing. So you're going to get a tunnel of Steve for one moment. And now you should be seeing my screen here. Maybe not. I wonder why. Oh yeah, there it is. It just lags a little bit. So right now you'll see that showcase on the top right, or on the right-hand bar. But if you go to the grid box there, you can switch to Q&A, and then the Q&A will pop up in that same right-hand bar, and you can follow along there. And I'm making that weird, crazy tunnel fractal thing. So I'm going to stop screen sharing and see if, yay, people are switching to Q&A and talking in the Q&A about their ability or inability to get to Q&A. Maybe questions will start coming in, so that would be good. Mehmet, can you undo the thing where I am presenter so that it switches back and forth between whoever's talking? Because I think it's just locked on me at the moment.
There you go.
Excellent.
Oh yeah. So actually, there's one bit that is a little bit less technical in nature that I sort of just wanted to comment on also. One of the data points that we are using is the influence upon section data that comes out of DBpedia. So the other, while sort of not something about a technical implementation, this is one of the data points though that we get the most squirmish about. We're the least comfortable with at our library, and it's partially because we don't necessarily know the provenance of that data. DBpedia just asserts it, but we don't know who actually said that Picasso was an influence on Gertrude Stein, or vice versa. And that's one of sort of the interesting things. That's one of the new and interesting pieces of information to consider when working with this data is how comfortable we are with each of the assertions. When we have things like just the facts, birth dates, death dates, alma maters, creative works that aren't represented in MARC records, those things definitely seem they seem like natural candidates for inclusion in a library catalog. We did include it in this sort of experimental version because we wanted to force the question and see how comfortable our reference librarians are with displaying that kind of information. But it also speaks to some of the different things that you see in some of the data sets. For example, I really like the Wikidata and the Getty data sets. I chose those in particular because they provide attribution of a lot of the sources of those data sets. So you might get a citation essentially in a kind of RDF structure that says, Gertrude Stein attended Radcliffe, and I'm citing this from the publication Feminist Quarterly Publications or something where it was asserted. And so that's really, I think, especially in academic libraries where we're concerned about these, the integrity of the data assertions, that there's going to be probably a premium on some of those kinds of data sets.
That absolutely makes sense. And I sort of, to add to that, I'm really interested in whether the library community is going to be in a position to start curating those kinds of additional links and additional assertions and additional data and building our own storehouses of it as well. There are a couple of actual questions coming in.
So let's see. Should we go? Do we go from the bottom up or the top down?
Maybe top down.
Okay. So for that first one, about using corporate bodies too, yes, we can. However, in our experience, the amount of data that we find in corporate bodies is much less. Usually, you can get that biographical or abstract information about one of those entities, but there, a lot of the data points that we're looking at right now are things that are attributes of people, birth dates, what their alma maters are. So I haven't seen the same kinds of assertions say about influences about corporate bodies. So it would really be a pretty small info card, just maybe one small blurb of a couple sentences.
Great. I think the other one a little bit further down is about linking out from subject entries.
Yeah, that's definitely one that we would like to be able to do. We haven't. I think in some of the examples, this is one of those things that I need to go back and just take a look at what is coming out of that JSON LD API. I think right now the only obvious URIs that I was able to find come from a field called creator in that data, but there's no reason that we wouldn't want to also do the same thing, especially when it's a biographical subject, because those also obviously do have the same kind of authority control in the catalog. Therefore, I think that Alma should be able to generate those LCNAF URIs.
And it would be great to for us to give that feedback to Ex Libris on the JSON LD APIs from Alma to make sure that if that isn't there already, it's put there in the future.
Yep. Yeah, and just so everybody knows, they have a linked data collaboration program. We're participating in that. That's why we were at the Aluna conference where we learned about the existence of this new API, or at least it's new to us. And so we're gonna try and sort of provide some feedback in that collaboration program based on this work, what it was like to consume that data.
Great. I don't see other questions coming in at this time, so I will sort of give it another moment or two for us to sort of chat while people are processing things to see if they have any questions, but we will make these slides available, and that code is already available on GitHub, so if things come up later, if you decide to like kick the tires on the gem and have a look, I'm sure you can get in touch with Steve either through email or through other contact information or through the issues on GitHub. And there is a new question about how you're doing the caching.
So we're just using the. Let me see. Would it be okay to just do the screen share and go back to a slide? Okay.
Absolutely, yeah.
So let me take a look here. See if I can find it. So you can kind of see, in our case, we're using a Ruby on Rails application. That Rails application has caching built in. I believe that if you don't specify an explicit cache, it's just going to try to do a file system cache. It would take that micrograph, as I called it, that bundle of n triples, and just write them to a temp location on disk. I think we probably have some kind of actual web cache up and running, which just sort of plugs into Rails if it's configured. But we're just using the web application framework cache itself, because that's sort of the point at which we're going to retrieve it. I don't think it's necessarily appropriate to do the caching in BibCard itself. BibCard is just really, like I said, just has those two responsibilities to get data that could be cached, and then once you have that, either just directly or from sort of a cached version, instantiate a person object.
Great, that's really helpful. And interesting too, because we've been having conversations in some other communities about whether we should be using things like linked data fragments to manage complicated caching of linked data URIs and linked data content, and particularly like subsets of responses from SPARQL queries. So the idea of just using a more generic web cache built into Ruby and Rails seems pretty compelling.
Yeah, and that's the thing this is an experiment to see, can we shrink down the data set required to make an info card small enough that it would just work within a normal web cache mechanism like memcached or what I think that might be what we're using. Otherwise we would, if that proves to be inefficient, then we might look into investigating our own local triple store, which would have the added benefit of then we could just sort of do queries against it and have probably better reliability.
Well, I don't see other questions coming in, and we have about 15 minutes left, but we don't necessarily need to use all of it. One thing that I did want to announce is that while we were on this call, the Developers Day website and preliminary schedule has gone live at developersday.info, www.developersday.info. I encourage you to go check that out if you want to think about joining us for Developers Day in Trondheim in just a little over a month. And we can add that to the showcase bar, whatever you call that, and we'll add it to the links on the Show&Tell website. I think if there's no more questions, I just want to say thanks again to Steve for this great presentation. I really am intrigued with this work, and I love seeing this really relatively new Alma functionality put to such interesting use so soon. I think it's a really good example of the kinds of things you can do around the edges of Ex Libris products with the APIs that they provide, and I really like that you're mixing this with other APIs. You're incorporating OCLC data and then using that sort of as a hub to go out and get all this other rich information that you can put into this space. Do you have any sense of when you might be ready to make this feature part of your standard UI rather than being on that beta? Have you had conversations at University of Wisconsin at all about that yet, or is this sort of early preliminary beta stage at this point?
It's still in the early preliminary beta stage, but we have something up. It works in production, so any people could evaluate it in the context of any title that's sort of active in our catalog. We do want to probably have our web designer give this sort of a special treatment. Right now, we just basically gave the implementation some very plain markup in the HTML that sort of gets generated, but we know that we would want to probably visually offset it. Say, hey, what does the rest of the web know about Pablo Picasso? Just to sort of, again, be clear with the provenance on where particular data sets come from. We want to kick the tires. We want to, we've talked about, but don't really have a concrete plan for what happens if some sort of offensive data sort of slipped in. We don't want to promote that. We would need a mechanism to handle that. So there's just a couple of practical considerations for that, but we're going to start getting some people together and evaluating, do we like this enough? Does it get folded into the production catalog, the main URL?
Well, all the more reason to say that I really appreciate your sharing this sort of early beta and talking to the broader community about it in order to get feedback and get ideas, and also let us learn from this. This has been great.
Okay. Thank you.
I guess that's it for our third. What is this? Our third show and tell, fourth show and tell, whichever it is. Some number of them, but do get in touch with Mehmet or John or I or Laura or Megan or Lucas, who are the deputy coordinators of these groups. If you have, or actually anyone else on the working body for these groups, if you have any ideas for additional show and tell topics or think you might want to present, and feel free to get in touch with us or Steve if you have any questions about this presentation. And I know I'm going to pull this code down and have a look at it, because I have a bunch of Rails stuff anyway that's in various different, in the context of like our Hydra and Blacklight ecosystems, and I want to see how easy it would just be to drop this in there and see how it works. So thanks again for this, Steve. This was great. And thanks everyone for joining us. Yeah.